project was about projectile motion. So what is projectile motion? First you need to know what an actual projectile is. Projectile is an object that is given an initial velocity and then follows a path due to the effects of gravity. For example, like a thrown baseball, and even these water droplets are projectiles, and also a bullet shot from a gun. And a projectile looks like this. Okay, that's what a projectile looks like. Right? So projectile motion is the study of projectiles. Projectile motion is studied in physics and is the study of the characteristics of a projectile, such as flight distance, height, and velocity. In the late 1500s, Galileo studied projectile motion. He discovered three key principles of projectile motion that are still used today. One thing he discovered was that projectiles actually travel with follow a parabolic or rainbow-like path due to gravity. This slide shows what a projectile looks like. He also studied the effect of the mass of a projectile. Okay, so if I had a 15-pound bowling ball and a penny, and I went on top of a skyscraper, I dropped them at the same time, how many of you think that the bowling ball hit the ground first?
Raise your hand.
Alright.
There you go.
So, I don't have a bowling ball or a penny, or a skyscraper, so I'm just gonna, so this has a lot more mass than this ping pong ball, and I'm gonna drop them at the same time and see which one hits the ground first. Ready? Yay, alright. So, so as you can see, they hit the ground at the same time. He discovered that the mass of an object is not a factor, and as I just demonstrated, two objects of different mass fall at the same rate due to gravity. One key principle of projectile motion that Galileo discovered had to do with understanding horizontal and vertical components of the motion. This is a graphical depiction of the velocity of the projectile. If I throw this ball, the red arrow called the vector shows the projectile's velocity. So this red arrow is the initial velocity, and it can be broken into two components. The horizontal velocity, represented by the yellow arrow, is how far a projectile travels, and the blue arrow represents the vertical velocity, is how high up or down a projectile travels while in flight. Before telling you what he discovered, though, I would like to demonstrate the principle of this video. If I was to throw this ball as hard as I could, and it would hit the ground at some point, right? So if I drop the ball from the same height, it would hit the ground at some point. And do you think that the thrown ball or the drop ball would hit the ground first? Probably the drop ball, you think. I will have a video here that lets you see for yourself. I'm going to roll a ball off the table, and when it gets over the lip of the table, I'm going to drop a ball. Space bar? No. Just go to the video.
How many takes did that take? That must have been
I think we got lucky on that one. It was like the first 3 or something. Yeah, as you can see, they both hit the ground at the same time. Here's a graphical example of the video demonstration. The horizontal arrows represent the horizontal velocity, and the vertical arrows represent the vertical velocity of the ball. The length of the arrows represents the magnitude of the velocity, and the longer the arrow, the faster the ball is moving. In the horizontal direction, there are arrows for the roll ball, but none for just the drop ball, because there's no initial horizontal velocity. In the vertical direction, the arrows are getting longer as the balls reach the ground. This is due to the acceleration of gravity, so the balls are moving faster and faster as they fall. But notice how for both the drop ball and the roll ball, the lengths of the vertical arrows are the same. See, this is the same length as this, which means that they will hit the ground at the same time, whether or not it has horizontal velocity. The key principle here is that the horizontal and vertical velocities have no effect on each other, and you can study them separately. This greatly simplifies the evaluation, and this was the key principle for the experiment that I performed. my experiment, I used the principles of projectile motion to determine the muzzle velocity of a Nerf gun, and it is very important to always wear your protective gear. In my experiment, I used two methods to calculate the muzzle velocity, a vertical method and a horizontal method. Since the vertical and horizontal components have no effect on each other, I was able to focus on either only the vertical motion or only the horizontal motion to estimate the muzzle velocity of a Nerf gun. I was then able to compare the findings to confirm the results of my experiment. I hypothesized that the muzzle velocities determined using the horizontal and vertical methods would be exactly the same. For the vertical method, the dart was shot straight up. I used the level to make sure the gun was perpendicular to the ground. In the vertical method, we calculated the initial vertical velocity, which is based on the flight time of the dart. The longer the flight time, the higher the vertical velocity. Because remember, the vertical velocity affects the height of the projectile. The muzzle velocity is the initial vertical velocity. For the projectile motion equation for vertical velocity is shown here. We know that gravity is constant. We can measure the initial height of the dart as shown here. The only thing we don't know is the flight time. And I shot the Nerf gun and used a stopwatch to time the flight of the dart. Okay, we did 5 tests. The average time was 2.12 seconds. The initial height was 5.125 feet. And gravity, which is constant, is 32.2 feet per second. And the muzzle velocity was 32 feet per second. For the horizontal method, the dart is shot parallel to the ground. In the horizontal method, I calculated the initial horizontal velocity, which is based on the flight distance of the dart. The farther it travels, the higher the velocity. As I mentioned before, horizontal velocity affects how far a projectile travels. The muzzle velocity is the initial horizontal velocity. In the horizontal method, the projectile motion equation for initial horizontal velocity is shown there. Again, we know that gravity is constant, and we can measure the initial height of the dart, as I showed in the vertical method. The only thing we don't know is the flight distance. In this method, I shot the dart gun and measured how far it went before hitting the ground. I did 5 tests. The average distance was 207 inches. The initial height was 55 inches, and gravity, which is constant. And the velocity came out to be 32 feet per second. My experiment conclusion was that vertical method and the horizontal method both had a muzzle velocity of 32 feet per second, and this demonstrated that my hypothesis was correct and confirmed my results. Projectile motion is used in the military to shoot like artillery shells and missiles. Projectile motion is used in the aerospace industry to launch spaceships and launch satellites. Projectile motion is used in ballistics and forensics. Ballistics is the study of guns, and forensics is used in crime scene investigations involving guns. Projectile motion is used in track and field, like in the shot put, and the big guy, and that's it.
This assignment would have given you extra credit for determining the equations for the problems.